Hello. We are starting a new chapter. I skipped chapter 9. So chapter 9 is like it is really, of course, that is important, but I think chapter 10, 11 are more important and more useful for you, so I decided not to include chapter 9 in our course. So let chapter 10, the keyword in chapter 10 is panel data. So we will extend the regression model to panel data. So we will like the basic framework is pretty similar, but it will be very interesting to see what we can do with panel data, which was not possible when we had non-panel data. So first, let's think about what is the panel data. Panel data, so in data, usually we can think about time dimension and cross-sectional dimension. Cross-sectional dimension means, say, kind of entities. You observe many individuals or states or companies or school districts or whatever, like a county, households. So you randomly choose some large number of entities, so they become cross-sectional dimension. At the same time, you observe many individuals, and also at the same time, for the same individual, you observe her over time. So every year or every month or every quarter, every day, like every week. So think about some examples. Suppose that you observe 420 California school districts in 1999 and again in 2000. So you observe the same school district's outcomes variables over time, about over 2 years. So you can observe their changes, how they change it over time, and like you observe two outcomes for each school district. Another example. So there are 50 states, and you observe, like say GDP over 3 years. Say GDP is usually calculated quarterly. So if you observe 50 states quarterly GDP over 3 years, then you have like uh, 12 times 50 observations. Uh, it depends on the interval of like on the variable how often you observe or measure the variable. So and again the idea is you have 50 states and the same states are observed over time. So once, twice, and like 3 times. And say data on 1,000 individuals in 4 different months, then total observations become 4,000. It's more intuitive. So you observe like 4,000 individuals over time, over 4 months. Um, so in all of these examples, as you can see, there are two dimensions: time dimension and cross-sectional dimension. So using those two dimensions will help us analyze the data better. And here is a notation. Here is the notation. So as we have two dimensions, we have to have two subscripts. So there are two indexes. One is for entities, the cross-sectional units, and the other is for the time period. So usually I is for individual or entity, cross-sectional unit, and we usually assume that there are n number of entities, n number of individuals. So previously, in the previous chapters, we only consider this dimension. So like school districts, or what we considered like earnings across people at the same time. So only we observe many different individuals or schools, states, but there was no time dimension. But now we have time dimension t. It could be year, could be month, could be quarter, could be week, could be day, hour, whatever. It's just time dimension. And capital T is the number of time periods you observe. Like if you observe 5 years, T will be 5, capital T will be 5, and it may be longer or shorter, but you need to have at least 2 or more periods so that you have to do at least one repetition of the observations. And then if you have only one regressor, like X and Y, and both X and Y depend on I and T. So obvious. So for an individual I, in year T, at time T, you observe X and Y. That is denoted as XIT, YIT. And if you have more variables, it's straightforward to extend the notation. X1 IT, X2 IT, up to XK IT. So again, I individual at time t, and you observe K regressors and 1 Y. So just we are replacing I with I and T. You allow 2 dimensions. And some jargon, longitudinal data. So panel data, I think in economics, panel data is more common, but maybe in statistics or biostatistics, longitudinal data this term is also usually used. And also there are 2 different uh, uh, assumptions on the panel data structure: balanced or unbalanced. Balanced panel data means you observe the same people like over the same periods of time. Say if, for example, and also of course the opposition is the opposite of this balanced panel is the unbalanced panel. When you have unbalanced panel, if you, like, say, for example, for an individual you observe over 10 years, but for another individual you observe over 5 years, then it is panel data. You observe like many people over time, but the time periods can be different from a person to another. Then we call that data unbalanced. So, but in this analysis, in our textbook and in our course, we are going to consider the balanced panel only. Unbalanced panel requires just very annoying notation. So just to avoid the notational problems, it does not cause much difference even if you use unbalanced panel. Okay, then why are panel data useful? What's important here is, as I said, you observe 2 dimensions, time dimension and cross-sectional dimensions. Then, so you may think about 2-dimensional effects, like, for example, think about, for example, stock market. In the stock market, you observe the stock market, like, say, every week or every month, you observe stock return for a single stock, a single firm's stock, weekly or monthly or yearly, whatever. So you observe, say, 500 firms, like from 2000 up to today. And then, in this case, if you think about 2008 and 2009, at the same time, all the stocks have fell a lot. Like, say, last year. Say, just simply last year, 2020, in March, due to the COVID-19, all the stocks fell by like more than 20%, like 20%, 30%. So that's a shock that is common to all the firms at the same time. So it is about the time dimension. So at a specific time dimension. Or like on the other dimension, you may think about what, say, Tesla, or what stock would be more interesting, say Bitcoin or Tesla. So like compared to any other stock, Tesla increased a lot last year. Like it fell down a little bit. So then it is just only specific to Tesla. It's that kind of increase is extraordinary. It's not normal. So then there must be something related to Tesla. Of course, Tesla is doing quite something different from the other companies. So that's why. So that means Tesla is special in some sense. Even if we do not observe that, we can see that from the data. We have observation from the observations. We can like guess Tesla is something different. Um, so we may do something like this, exactly like this. So there may be some factors that vary across entities but do not vary over time, like vary across entities. It's specific to, there must be some factor specific to Tesla, factor specific to Amazon, factor specific to Microsoft. So they have their own characteristics, but it does not change over time. It's quite persistent over time, or and this hit like this like a persistent effect may could have caused omitted variable bias, even if like it is not directly observed, but just having panel data fixes some kind of omitted variable bias. We are going to study that later. And so the idea here is, so if and like so this, so something persists, that persists over time includes anything you do not observe and anything, all the omitted variables that do not change over time. So I don't know what is good or what is special about Tesla stock, but uh, if you could observe all the characteristics of the firm, then it would be great. But without observing them, the omitted variable bias can be handled by panel data structure. So that's something very interesting, and you will see how we can handle that like in an example soon. So in the next video, I will start an interesting empirical example, and from the example, I will explain what we would like to do and what is why we need to consider panel data structure. Okay, thank you for watching. See you later.